Hey, what's going on, guys? Genzi here. In this video we're going to be doing some chess piece image recognition from the screenshot taken from the certain website we're supposed to be running our chess bot to play chess on. So if you're interested, without further ado, let's actually start. And here is the current working directory, and before anything else you need to make sure that from the previous tutorial you did obtain the list of images from the screenshot like this. And in order to make sure that in this video everything is going to be working, we need to reproduce what we currently see on a screenshot. I mean, obviously there might be something different on the terminal, but the most essential thing is the top left corner of the chessboard, and the width and height of the chessboard should be exactly the same as it was on the screenshot used for the purposes of creation this piece images for detection of the pieces in the image contained in a chessboard. So I hope that's clear. Okay, now let's go to leechess.org. As far as this can be applied to whatever site, but my current set of images is tuned to work with Lichess, so I hope that's clear. And let's create a game versus computer. Yeah, standard, unlimited. Let's play with the white pieces, doesn't really matter that much. Which in particular do we consider? And here we have the exact board size and position as in the previous tutorial, so I hope it's clear. Okay, and now let's open the terminal in the current working directory, and by typing Python 3 chessbot.py, I'm gonna run it. But before actually running the script, we need to make 100% sure that we have the browser window with the chessboard being located exactly where we want it to be. Okay, so this is very important, this is very essential. This is very essential. So now when I have this absolute coordinates and the width and height equals to 400 pixels, which I know it is, only in this case I can run the script. For otherwise it's just not going to be working. So pay attention to this when you're going to be playing with this at home, if you're ever going to be doing this. And here we got a screenshot. So now we would be recognizing piece by piece. So the order doesn't matter really, and this red box is highlighting the detected pieces on the chessboard. So we have a black king, queen, rooks, bishops, knights, pawns, and the same for white pieces. So this is how it works. So it's quite pretty simple. And this is it regarding the demonstration. And now without further ado, I would like to quickly walk through the source code, because it's really essential what's going on there. So in the last video I said that we would be doing image to FEN conversion, but for now I decided to focus on the piece image recognition, and we'll go to the FEN a little bit later. So even though despite this commentary, so I'll need to fix this a little bit. So let's quickly walk through what we have in the source code at the current state. So packages, quite pretty clear. So one of the most essential things, so board size, and exactly the same as we had in our script to extract pieces. So it's a copy paste from this part. Okay, the cell size is self-explanatory. So board size divided by 8 squares. Hard-coded top and left coordinates of the board. Confidence is the parameter to specify how precise the pattern recognition is. So this is needed in order to distinguish between let's say white pawn located on light square, on dark square, or on highlighted light square, or on highlighted dark square. So I hope that's clear. Yeah, and the piece path as well. So this piece names would be used to map pieces to the FEN characters. It's not used, so we can ignore it safely. And locate piece routine actually draws this rectangle as you've seen on the screen. So I hope this is clear as well. So this is just a debugging function. And the most essential one is this one, so recognize position. Well, it doesn't yet convert the board image to FEN. I think I just split this into two functions to make it more clear and more didactic. But here is the deal. So we're taking a screenshot using by AutoGUI screenshot. We convert into OpenCV specific color map, and then we'll loop over all the piece names here, over all of the strings literally, and then we trying to locate all the objects on string. So we're using the certain name as an argument to locate all on screen method from PyAutoGUI. We're using the piece path and appending the PNG. So eventually we do reference pieces from here. So I hope it's clear. So we're referencing pieces from here. So taking the black king, taking this image and asking the question whether the black king is on board or not, then taking like black knight and all the pieces one by one. So there might be one or many occurrences of a certain piece on a chessboard. So I hope that's clear as well. And one of the most important things. So due to the fact that we're using this confidence parameter, which means that the image might not exactly match, but some pixels might have some different values. This produces so-called noise. So it means like, well, visually it seems like it just doesn't draw just a single red square around a pawn, let's say, but it might be drawing like 3 or 4 or even 5 or even more squares, because they all kind of like might potentially be treated as the recognition, but that's the noise. So in order to make sure that we do not store that noise, because this would horribly mess up the FEN that we're supposed to be doing later on. So for that purposes, we're using a certain threshold, and we're just subtracting the current. We're subtracting the available positions, coordinate, left coordinate and top coordinate. We're subtracting current location, left and top coordinate was supposed to be appended, and if it's less than the threshold, in this case we just enable this noise flag, breaking out of the loop, and if we have the noise, we just continue through the loop. We're not going to be dissection pieces, so we're not going to be appending a new piece by 10 pieces. I mean the coordinates like top, left, width, and height. So we're not going to be adding that to this piece location. So all this kind of lists are getting appended by new pieces, and by same piece again, like it's just a matter of the top left coordinate and width and height of the squares. So then we would be distinguishing by those coordinates what particular square does a certain piece belong to, and that would be composing, like generating our FEN. So if we have a noise, then we continue through the loop and not detecting and not appending piece. Otherwise, we do append the piece, and it returns the screenshot and the piece location. So the screenshot is only needed for debugging purposes. So then we can loop over all the piece names, and we just can send this screenshot. We send the screenshot to the locate piece just to display this on screen. Okay, so I hope it's clear. And also we can we use this picture to draw red rectangles on, just to visualize those coordinates, like those squares responsible for a piece that is being detected. Well, okay guys, this is it from my side. I hope it's clear. So I really hope that in the next video we'll already go for converting this, like associating these coordinates and piece types with the actual board squares, and eventually come up with the FEN string, and then we're going to be using the FEN string to initialize the board in Python chess module. This is it from my side. Thanks for watching. Until the next time, and take care.